ocean temperature for the fourth consecutive year last year. The study was published Wednesday in the journal Advances in Atmospheric Sciences. It found the 5 hottest years for the world's oceans all happened in the past 6 years, and oceans are continuing to warm at a fast rate. Researchers have examined temperatures from the ocean surface to about 6,500 feet deep, going back to the 1950s. Oceans are a good indicator of the impact of climate change because they are less affected by seasonal change and day-to-day weather cycles than air temperatures. They also absorb most of the world's heat.
Today, the members of the Science and Security Board moved the hands of the doomsday clock forward, largely, though not exclusively, because of the mounting dangers in the war in Ukraine. We moved the clock forward the closest it has ever been to midnight. It is now 90 seconds to midnight.
We're still putting 162 million tons into it every single day, and the accumulated amount is now trapping as much extra heat as would be released by 600,000 Hiroshima-class atomic bombs exploding every single day on the Earth. That's what's boiling the oceans, creating these atmospheric rivers and the rain bombs, and sucking the moisture out of the land and creating the droughts and melting the ice and raising the sea level and causing these waves of climate refugees predicted to reach 1 billion in this century. Look at the xenophobia and political authoritarian trends that have come from just a few million refugees. What about a billion?
In addition to taking some excess carbon dioxide from the atmosphere, the ocean has absorbed more than 90% of the excess heat resulting from climate change. Warmer ocean waters lead to sea level rise as the water expands. Warmer water can also feed stronger coastal storms, which draw energy in the form of heat from the upper ocean. The ocean absorbs and releases heat more slowly than the atmosphere, helping to stabilize the climate. But that also means surface temperatures will continue to increase even if greenhouse gas emissions were to stop immediately, as the ocean slowly releases some of the excess heat it has absorbed.
Welcome, Jim Massa. Good evening, Jim, and welcome to the Little Humble Environmental Coffee House.
Howdy, howdy.
Howdy, howdy.
How's everyone doing?
Well, we got a full house starting anyway. It says Midas Lisa, Jim McHenry. We went earlier because I kind of think during the winter for me, 7 o'clock is decent. And I know it's really a lot earlier for you up there in Alaska. Is it dark all the time at your house?
No. Actually, yesterday we went over 6 hours of the sun above the horizon here in Fairbanks.
Ooh.
And at Utqiagvik, the other day, they saw the sun for the first time in 2 months.
In 2 months?
Wow. So we're starting to get to the point where, and now here in Fairbanks, the sun is higher than 5 degrees elevation. So that means that the sun, while it's up in the sky, will be starting to impart some solar radiative effects into the atmosphere. Because usually when it's below 5 degrees, the sun just is like, yeah, it's there. It's not imparting any heat, really.
So you're going to get a little heat, a little heat in Alaska. Jeez. Oh my God. It's so good to see you. Happy New Year, by the way.
But it's by the end of this, the New Year, but by the end of this month, we'll be almost at 7 hours of daylight. We're gaining close. Basically right now. We're gaining like 6 minutes and 40 seconds every day. Soon it'll hit 7 minutes every day.
Wow, you've got it down to a science.
I actually plot these.
You do? No shit.
Yeah, seriously. I make a graph of it. It's really interesting because if between the circles, the Antarctic and Arctic circle, when you plot the daylight length, it makes a sine curve.
Oh,
The height of the sine curve, the amplitude is dependent on latitude. But once you get on the other side of the circles to the pole, then those curves switch between basically being a cotangent and tangent curves. So they reach asymptotes, which is full darkness, a full, you know,
and
daylight, and then it flips the other way and it comes down. So you can actually plot these very nice mathematical functions.
very nice. Very nice, Jim. I'm impressed. You know what?
This
I
is
don't
this is
plot mine.
called being bored and having too much damn time on your hands. But
Well, that's why you're back with me then, because we have to turn that boredom into an educational experience for people out there. And trust me, you do. You do. I mean, I watch your videos and I learn. Of course, sometimes I have to watch them twice. And I do. I will. If I'm not watching it, paying attention, I'm walking around doing things and I listen, I might have to actually then say, oh, I got to watch this second time so I can see the graphics and the pictures. But no, I learn. I think everybody out there will agree that this is good. So I'm glad you're back again.
good
Tonight
to be
we
here.
have, yeah, and we have a good a great audience, and it's great to see all of you. So we've got some stuff to talk about. Well, Jim mainly. I made the opening video, so evidently everybody knows that's kind of like the sliding into the show using the clips also from what's going on, in the news. We may not get to talk about the doomsday clock, but everybody knows. We may not get to talk about, or do we even want to talk about Davos? No, we just want to talk about the oceans. So tell me where you want me to go, Jim.
Well, as we saw in the opening video there, when you start seeing basically mainstream media reporting on what's happening in the oceans, that's when you know that we're in a world of hurt. Because
Yeah.
they typically been ignoring this stuff. Now they can no longer ignore it. I've been, I'm not the only one, but there's been a bunch of us who've been warning folks of this stuff for years. Now, granted, I'm an oceanographer, so I better be keeping up on what the hell's going on in the ocean.
Yeah, I
But
would say.
but still, I've been ringing the bell about this, that the ocean and absorbing all the heat, absorbing the CO2 and the stratification that will ensue, which then inhibits sequestration to depth of heat and CO2. So now if that heat is not going to be sequestered, it's going to linger
Ooh.
in the upper layers. It makes it more readily likely, and just looking at basic physics and thermodynamics, that some of that heat will flux right back to the atmosphere, and that's what we're seeing. Look at what's happening in California with those massive,
Oh,
air rivers thing, with
yeah.
the precipitation slamming into there. Um, Look at the how much heat they have, the oceans have been absorbed. We'll be looking at some of these graphics in a moment,
Mm-hmm.
but we're just seeing we- we're seeing crazy weather events because the ocean heat is fluxing to the atmosphere. This affects the temperature pressure gradient, which affects the jet stream, and then you get crazy weather patterns, going from one extreme to the other.
Absolutely.
Precipitation bombs, sucking the ground dry, so you get drought conditions. Wet areas get wetter, dry areas get drier,
Mm.
and so on. So we are now seeing what the hell climate change looks like. We are seeing
Yeah,
it.
I think so. It's more than just that, of course. But if you look at you look at YouTube video clip comment sections, or you look at Twitter, and Twitter, you would think there's nothing. There's no such thing. Science? Are you kidding? There's nothing wrong with the planet. Everything's just fine. Everything's fine, Jim. It's all fine, according to social media. Idiots, bots, losers, people sitting in their parents' basement, whatever. Okay, so there's my little commentary.
Well, the problem is that, yeah,
Yeah.
planet Earth is going to respond and adjust to the physical conditions and parameters. What is bad is that it's not going to bode well for humans. That's the problem. But also with the rate
It's
of
not
change being
funny.
so fast, the faster that we've ever seen, the problem is that organisms are not going to be able to adapt fast enough. So there's going to be mass extinction because
Well,
of the
there
rate of
is.
change is just happening too fast, and they can't adapt quickly enough. So that's what I feel kind of what I feel really bad about.
You feel bad, and then you realize that the younger the people are, they don't know what they're missing. This is normal for them that, animals just die or they never even get to understand what was out there. Oh my. All right. Well, anyway, if we go down this rabbit hole, we will never get to where we are. But let's see. Jean already has a question, but I'll tell you what. Let's read it for Jean, and then if we get to, I'll save it for the end. Hello, Sandy. If you get a chance, ask Jim to please talk about how the temperature will affect the ocean currents and what will happen from that. So we'll save that one, Jim. That sounds like one that's right up our alley. Thank you, Jean. I wanted to make sure that you stuck around. Get the answer. All right. So let's get ready, and Jim, you'll talk about the slides. We set it up so we have our little slideshow.
Can we pull up the article first? Let's kind of quick
All
go through
right.
that one real
We're going to
quickly.
pull up the article first. All right, let's get the article going. It is right there. All right. Oh, wait, I don't want the big screen
Ah,
share. That's too big. I have a smaller screen share. I have one that's supposed to be like that. Okay, there we
ah,
go.
the main, of course, I know you will include the link in the notes there,
Mm-hmm.
but as you can see, the figure there, I created a larger version of that. We'll look at that later. But what's really cool is you can scroll down to where it shows the planet Earth, and they got that little slide bar down below
Yep,
that.
yep.
It starts in 18, what is that, 80 whatever, and then if you if you look at the where it is now, currently at this moment of the slide, you see that most of the planet is blue, meaning that when you compare to the baseline,
Yeah.
the conditions were cooler to the average. Then, as you slide it along during the years, you see it just gets redder and redder. First you see yellows and brown, and then you start seeing the reds and then that dark browns and so on as it proceeds over the years. This just shows you how much warming humans have caused in basically 140 years or so,
It's
just in that
frightening.
time frame.
It's frightening,
You know,
in my opinion. I mean, it's done, but lately I've been getting those little pangs of fear, and I hadn't had them. That I had successfully, I thought, handled it, and all of these things that are happening are bringing it back a bit. And you must
you
share that.
just look at what's going on here, and
Yeah,
look at the Arctic.
I
Look
know,
at the
Jim.
Arctic.
I know,
Yeah.
and I suppose that's why you're here. That's why Jen's here. That's why, so we can, and everybody in the chat, so we can actually, feel that we're not alone in this, and that we're not feeling like we're being gaslighted, and that we're the ones that are crazy, because I don't think so. I don't think so. All right. So anyway,
It's
now that
just
I got everybody all upset.
that's really what I wanted. That this particular article show, just to show you so we can watch the changing temperature as it just kept getting warmer and warmer over the years.
Yeah.
So it's very alarming, and there's nothing like a quick little 40-second graphic just to drive it home.
There you go. You're right. And it's a good article, actually. I mean, well, this website go to NASA, and there's always good stuff to peruse. So these links will be in there, and I'm sure a lot of you already know where to find the good stuff, like Jim found. So, all right, Jim. So let's start with the.
And by the way, those scientists there are on the Arctic ice. It's just
They're yeah,
they're standing on the
yeah,
yeah.
they're the guys on the Arctic ice.
I kind of used to do some of that stuff.
Yeah, I hear you, and I know you were damn good at it. I bet.
It's passable, but
Oh, stop. Stop. I think that, I've learned a lot from you, so stop it. It's we have to make ourselves feel good sometimes. Thank you. The world is tough enough, Jim. We all cross paths for a reason, and we're here doing it. So educate, please.
okay. So this is showing January to December temperature anomalies, and it goes back to 1950. So basically, the baseline is what was the baseline for that? Baseline I think was 1980 to 2010. I think was the baseline for
Yeah.
this one. I don't,
Well, no, it goes up to
and
2022. And then the other side,
yeah,
it's going, yeah. Oh, okay.
no, I'm
Yeah.
talking about the baseline. What years they're
Oh,
using to
here.
average.
Mm-hmm. Let me see.
You know, and and
Gotcha.
basically what they're showing is that when you compare, because these are anomalies, so these are departures from the average from basically 19, I think it's 1980 to 2010 or so, for that 30-year period, which is what meteorologists tend to do. When you look at that, aside from a few years going back into the 50s and so on in the 60s, just about every year has been above the average. This shows you, and if you look at this, it just keeps increasing and increasing. Now, there's a couple little dips here and there, and okay, spoiler alert, that's due to ENSO cycles.
Ooh, I was
And
reading
I'll
all
have,
about Enso. Read.
so that's what we're seeing
Mhm.
here. But still, the temperature just keeps getting warmer and warmer. The departure from the average just keeps going up and up and up.
Obsolete optics. Are you really a meteorologist? And what's Plumegate? What's Plumegate? I think he's playing with us. He's playing with us. People
Depends
are.
where you're at.
It's
It
okay.
depends.
It's what?
I was gonna say we can talk about plumes of sediment flow in the ocean.
Ah,
You can talk about plumes of
Plumegate.
volcanic ash. You can talk about plumes of smokestack ash. So
Plumegate
I,
sounds like a conspiracy.
yeah,
Group.
I can't speak to gate, but I can tell you what a plume is. you
Right? We have the
know,
plumes.
you fart, you let out a plume.
Yes. Plumes are us. Okay, he's being. I'm giving him the time. He's making everybody laugh. I'm a butcher. What's a cow? I'm a baker. What's a cake? I'm a fisherman. What's a boat? See, we have a little levity tonight, and we're leaving. We're letting. It's an interactive chat, and that's why we're here live. Yes, yes, yes. Oh, Plumegate. That's the radiation from Fukushima. Okay, somebody would get it. All right, Plumegate, whether it was real or not, but we're not equipped to do
Well,
that tonight.
it was real. I just didn't
No, no,
realize it.
no, no. Whether that people thought it wasn't. If it's
Oh,
a gate, you see what I mean? If it's a gate, then there's Russia Gate. What other gates? That's where people were questioning whether it happened, right? Maybe.
I guess
I don't
I
know.
do
I'm
know
not
that.
up to my plume
Yeah,
gate.
I do know that there was massive radiation leaks into the ocean from Fukushima, so we'll just leave it at that.
Oh my god. Oh my god. Oh, hi CB. He said now Antarctica's warmer than normal. That's a lot of lots of breakage this year. You want to talk
Yeah,
to that
and
before we move?
I've been doing some videos on that recently, how there's the warmer oceanic waters are getting under the ice and melting it from below. So it's not just air temperature. Um, and we're seeing, there's what was it, Chris Van Stiergen? I think he does post a lot of stuff on Antarctica, and there are lots of satellite images coming out in the last few days showing a lot of splitting and breaking of some of the ice sheets. Very
I
alarming
saw that.
because as these ice sheets break off, eventually they make their way into warmer temperate latitudes, and they melt and they contribute to sea level rise. And Thwaites Glacier, which means Pine Island right next to it, are in very, very real danger of collapsing very, very soon. There's a lot of alarm among the scientists who study that, saying that the situation has gotten critical.
Wow. Very critical. We're being
Wow.
yeah, Dale, we don't know Plumegate. He's making us feel bad. Probably in the back of my memory banks. Give us a pass. Okay, anyway, um let's go to our next one. And that was, and I'm really happy we're doing an interactive night with everybody out in the chat.
Okay, so this is the
You're
global
global.
temperatures
Hmm.
for the month of March from 1880 to 2022, and they fitted a regression line that you can see there. And when they say March warming plus 0.85 degrees C, that is the coefficient, that is the slope of that regression line.
Okay,
And basically that equates to 1.53 degrees Fahrenheit per century warming.
per century.
per
Wow.
century per century warming. And again, we see what's going on, that yeah, we had a couple of years in the 40s and scattered in the 50s and 60s where it was a little warmer than the baseline average, but basically from 1880 through the end of the 1930s, it was cooler than average. Look, you had 1 year there, but
Right.
then starting about
Yeah, that one
1980,
year.
everything is warmer again. And if you looked at in about, what is that? Looks like 2016 or so, the
Yeah.
warmest year on record. That very tall spike there. That was a strong El Nino year.
Oh yeah, there's that tall spike right there. I don't think my pointer's working on the overlay, but there's the spike. Yeah. And that was a what name? It was a La Nina year?
It was a very strong El Nino year.
El Nino year. El
El Nino.
Nino. It was an El Nino year. What happened in 2016? I could tell you what happened, that Bernie was running for president. I mean, oh
And
God.
about 2010, 2011, you see a little dip down there. That was a strong La Nina year.
All right.
But even with that, it was still warmer than the baseline average. Further evidence that planetary. These are measuring atmospheric temperatures. The last one was for the all year long everywhere on the planet. This one was just looking at the month of March, because March is typically when we're reaching equinox season, and so there's going to be some turbulence in the atmosphere because of that. And we can do this for every single month of the year, an individual snapshot of month of the year, but you're going to see the same result. You're going to have this basically a continual rise in temperature.
Jim, and
It's right there for everyone to
it's
see.
right there. But that continual rise also leads to a continual negative experience for the animals in the ocean. And I wondered, did you read the story? And do you think this has anything to do with anything about dolphins in the Bronx River? Did you read
I
that,
have not
Bronx?
even heard
Okay.
anything about it.
There
I didn't
are
hear about
there
that.
were dolphins in the Bronx River, which is the outlet from the Hudson River to the ocean on the Atlantic coast off of New York State. And somebody sent it to me, and I didn't have enough time to research dolphins in the Bronx River, but in my whole life, I have never heard of dolphins in the Bronx River. So I just wondered if that's now a new migration pattern for dolphins that are usually in the southern warmer waters. I mean, there's going to be all kinds of stories like this. Whales that beach themselves for no reason, and part of it's got to be besides just environmental degradation and, plastics and pollution, heat too.
I have done videos discussing that
Yeah.
very problem. That because of the warming oceans, organisms are moving.
Yeah, they
They're
drive
trying to move.
migration patterns
They're not just migration. They're relocating. Period. They
forever.
need to find temperatures that are more suitable for them. But then when they move to find, okay, this is more comfortable temperatures, then they have like, well, where the hell's my food? They still have to find the food sources. So, if an organism's in the water, they have a couple of choices to find the temperatures that they like. Go deeper
Hmm.
or move forward, move to higher latitudes. And but then when they do that, well, where's their food? It's not like if you're a turtle and oh, okay, you're a little cool, so you crawl out of the little pond, you climb onto a rock or a tree trunk, you sit in the sun, you warm up. Oh, I'm a little hot, and you overheat, so you take a dip. It's easier for animals like that to thermal regulate versus organisms in the ocean or any deep, large body of water that they're immersed in the water. It's more difficult for them to thermal regulate, and oftentimes you find out that some organisms actually metabolically burn themselves out.
That's a shame. And that leads to extinction. My
It
God.
does. because,
Yeah.
but even if they're able to maintain, they're spending so much energy into running their metabolism that they don't then have enough energy to put towards production of gametes. Then they can't spawn, and you don't
Right.
have year class, uh, you know, that kind of stuff.
Yeah.
You don't no new cohorts.
Big spiral. It's circular firing squad to say, talk about they can't fire, right? Oh my God. Um, Oh, wait, Gene had something here. Authorities keep the Bronx River stocked with a plentiful supply of fish, which they believe may have drawn the dolphins in. Well, that's cool. Okay, so we don't, I guess they came all the way up north because they smelled them. It must be that they're starving other places. I wonder. Oh my gosh. So if the Bronx
Well,
River is stocked with fisherman fish.
Well, we can talk about this now with the
Okay.
continual ocean heat that's going on. I just did a video on this. My last video, inhomogeneity is increasing the oceans, i.e., increased stratification. When you have increased stratification,
Oops.
and where the stratification becomes basically prevalent most of the time, then you're not going to get the mixing of the nutrients for the phytos for them to do their thing. And you know what? That ultimately leads to ecosystem food chain collapse. I mean, you need stratification, but after you have a good mixing event, you mix the nutrients into the photic zone, you stratify the water to stabilize it so the productivity can take place, but then it's predicated on the stratification breaking down at
Right.
some
Yeah.
future point. And now it is no
Mhm.
longer breaking down, it is staying pretty much permanent. Now, the tropics are a region of historic low productivity because there pretty much is a near permanent thermocline year round. We are now starting to see this permanent thermocline slash pycnocline setting up in temperate waters, which is where most of your productivity, temperate and polar waters, are where most of the productivity in the oceans take place, plus along coastlines.
For those of you who don't know, can you just tell them again what a thermocline is? If there's
A
people.
sharp change in temperature,
Okay.
and a
So
pycnocline is a sharp change in density.
makes
So, for
sense.
example,
Thick no. Okay.
let's use this. And by the way, shameless plug here, but I did a video on the overturn mixing and stratification. It's a lengthy video, but check it out. I explain it all in gory detail. But yeah,
All right.
but let's take an example of a lake, a typical what's called a dimictic lake, which is a 2 mixing per year lake, temperate lake. Uh, you might have summertime. Those upper layers are nice and warm, and if you go down, say 10 meters or so, you'll find that you have pretty much uniform temperature. It might be, say, something like 15°C, some nice
Yep.
temperature like that. And all of a sudden, you hit a layer, it's like, bam! It's
Bam!
now like 8 degrees. It's like 8 degrees C, and it keeps getting colder and colder as you go down to depth. You have gone through the thermocline.
All
So,
right. I took the trip. We went through the thermocline together. That was pretty exciting. All right. Well, now that we did that, are we
in
going
the oceans,
next?
because density is
Oh,
determined by not just temperature, but salt content, the salinity. So we see more typically changes in the pycnocline. Now, in the tropical regions, temperature is more the deciding factor. In polar regions, salinity is more the deciding factor, which is why we concentrate on the halocline in the Arctic Ocean,
all right.
because the water is typically cold, but it's the differences in salinity.
And it's a higher rate of it's higher salinity in the north.
Actually, polar waters tends to be lower in salinity than tropical waters.
But that's changing?
What's changing is all the fresh water dump.
Yeah.
What's changing
Yeah.
is not only the fresh water dump, but the actual loss of sea ice is actually starting to increase the salinity in some cases, because you get the melting of the ice, which lowers the salinity, but then you get double diffusive properties. It's very complicated, and then the salinity at depth increases.
It's
The
all
Arctic Ocean
complicated.
is the Arctic Ocean is incredibly complicated for such a small body of water because of all these dynamics. Another thing to keep in mind is, with the loss of, say, cloud cover and the heating up of the atmosphere, going back to the tropics, we're increasing the rate of evaporation, which then further increases the salinity of tropical waters.
Oh boy.
So, which increases the density. So, everything's dynamic. The ocean's a
The
very
oceans
dynamic
are
place.
dynamic. The oceans are amazing. They're still talking, I think, about Fukushima. And guess what? In my memory banks, because I listened to many Fukushima people, but years ago, I got it. It came back. So sometimes putting me on the spot is good for jarring the old memory banks. All right. Uh, where are we? We could just go, the oceans are fascinating. They fascinate me. And we're going to go to we already went here. Okay. We're going to the less smoothing. Well, it's called lowest smoothing. I need the highest smoothing. All right, Jim, take it away after my bad jokes.
Okay, this is again showing temperature anomaly. The the very light gray with the ups and downs is showing the annual mean. So, of course, the up and down reflect seasonal variations. And low S is basically a type of regression
Yeah.
analysis that smooths it out. So basically, it just basically averages things out over time. It's a time
All
series
right.
analysis. Again, we see that they started in 1880. This is under the vital sign, uh, web page we pulled up earlier, and we can see starting in the mid 70s or so, in the 1980s, it's just basically climbing and climbing and climbing. It's again,
That
it's
it
another way of
is.
showing the data, and it's showing the departure. And when you look at it starting in about the mid 70s, the departure is about another 1 whole degree centigrade
Wow.
warmer than before, than the baseline.
How can
So
people
that's
deny that this is happening? How can people deny this, Jim? How? Oh my God.
they're, they're ostriches.
I don't
Shove
get
their
it.
heads in the sand.
And I
So
don't,
so when you think
yeah.
So when you look at this here, you've got in the last, what would that be, 55 years, 1975,
Yeah.
45 years. In the last 45 years, so we have already gone 1 degree C above the baseline that this is computed for. So then if you extrapolate all the way back to 1750, not 1850, 1750,
Mm-hmm.
we then I make the argument, and I've seen data that backs this up, which is
All
why I
right.
make the argument that we have actually warmed more than 1.5 degrees C already. So
Ugh.
this whole talk about keeping it under 1.5 is just smokes and mirrors. It's called moving the goalpost, so it doesn't seem so bad. Yeah, it's bad. And when you look at the analyses that the PIK group out of Potsdam, Germany did, and I did a two-part video on this, tipping points for the planet. They concluded that an increase of 1.3 C is enough to cause disruption and chaos in our weather system. Well, jolly geez, folks,
Yeah.
what the hell do we have going on? They
Oh,
called it. They're
it
right.
overwhelms me. And then I read this thread today under one of your graphics, a thread that people are saying, oh, the world is greening and it's going to be wonderful and it's taking the CO2 and there are places that are green that have not been green in millions of years, blah, 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 without understanding that green comes with a huge price called your fucking ass will be extinct. All right. Well, anyway.
Well,
Sorry.
that's a misconception a lot of people have. Oh, warmer temperatures and CO2, that's been good for plants. Well, no, because plants, like every other organism, have a preferred temperature range. And when it's warmer than their preferred temperature range, you know what's going to happen to those plants? They're going to lose a lot more water out of their stomata then they can
Yes.
suck up through the ground. And the ground is drying up, so there's not even any water to replace it. They do what? They wither and die. And a lot of those plants that are withering and dying are plants that we need for crops, which
Always a
is
pleasure.
why crop yields are decreasing,
Yeah.
as well as nutritional quality content of it.
You know, if I mean seriously, if you heard Al Gore, I don't care what all those everybody says about him per se, that he flew there, whatever. The man was right in his rant that I played in the beginning of the show. He's completely right. Nobody gives a shit. And then they put it was even more. I mean, ranting about putting an oil executive. That was what Antonio Guterres about putting an oil executive in charge of COP. We are done. I mean, no one cares. And there's a huge shift to try to, I mean, yes, green energy has its troubles. We know we all read, the bright green lights and all, but there is a concerted effort to just keep on drilling and companies approving drilling permits. And it's one big gigantic gaslighting mess.
Well, look at the recent series of videos that did covering the COP27, where they're just basically kicking the can down the road. Canada won't phase out fossil fuel. They won't do shit about methane. They won't, they're just not doing anything. And look what's happening now. Okay, so you have Russia invading Ukraine. So you got all the European countries scrambling. So instead of using the golden opportunity to quickly develop and implement, solar energy, windmills, and all that stuff. Oh no, let's drill some more. So it's just like, well, that kind of bloody defeats the whole damn purpose.
Yeah.
That's only
Well,
going to exacerbate shit.
have you run into James Pettymore on Twitter, the guy that is now all of a sudden in all our feeds who says he was a 40-year retired miner all over the world and he is ripping the mining and green energy a new asshole. And some of it is sound, but I think when you go to the rest of his Twitter, he's like a kind of a right wing. I get the idea that he's being put up, but some of his stuff is good. It's not great, and grow. Why? I'm saying growing solar farms. That's pretty pathetic. that I said growing solar farms. What is growing on a solar farm, Jim? Can you explain?
Well, someone put out an interesting tweet. I forget who it was, and made a really interesting point. Says stop referring to solar and wind as green energy. They're solar harvesters,
Okay.
and that the equipment lasts about 30 years, so it has to be replaced. And to replace it, you have to do what? You have to extract the raw materials. And usually to extract the raw material, you need to go in there with big heavy machinery, which
Big.
runs on, wait for it, diesel.
Yeah, diesel.
So
But I guess what they're looking at is the cost benefit. They're looking at, okay, there's an upfront cost of burning fossil fuels and using these things and mining to get to an energy source that will not burn carbon for 30 years or whatever. But
and that's a valid approach. I've been arguing that in order to really, do such things, you need to, in this case
I
here,
hate the
do
mining.
you need to do a budgetary analysis. You need
I
to do
know.
a carbon budget analysis. It's just no way around it.
But
I mean,
people are
it's
saying
mundane
that's
work, but
bullshit.
it's important work.
Oh,
You have
carbon
to do the
budget.
heat budget. You have to, you
Mm.
know, it, you know, you do the carbon budget as to how much carbon is released to extract versus running your pickup truck, what have you. You have to perform those analyses, th- you know, and and then you say, okay, you perform it. How does it shake out?
Mhm.
Now, typically, it shakes out that, the carbon that gets burned to create that electric vehicle, and that includes the lithium batteries, okay, compared to the life expectancy of that electric vehicle and how much it burns, i.e., how much carbon are you using to plug it in, you know, if it turns out that that is indeed puts out reduced emissions, then you do it. It's as
Right.
simple as that.
Because we
Now,
can't
if you
fight
have
it. We can't fight
now
it, Jim.
if you also happen to be off grid where you create your own electricity and you have an electric vehicle, then you really are carbon neutral because you're grabbing the solar energy to create the battery to then charge up your vehicle. Whereas if you're attached to a power plant, then
Yeah.
how much is that power plant burning? You have to then that factors into your carbon budgetary analysis. So you have to. It's just like when we talk about the heat. How the planet's warming up. Okay, how much heat's getting sequestered in the ocean? How much gets flux from the ocean to the atmosphere? How much stays in the atmosphere? Etc. You have to do the carbon budget, the heat analysis. This is what I did a lot of my damn research on. What I was just doing, basically heat budgets.
But that's
Energy
not
in, energy out.
the carbon footprint that everybody's like, "Oh, you have to lower your carbon footprint." All right, we do our best. You're talking about budgets, different thing than the
No,
latest.
no, no. The carbon footprint is tied into carbon budgets. It's tied together.
All right.
Because if you use an electric vehicle and you know and the analysis turns out that you yourself are emitting less CO2 and water vapor, don't forget, water vapor is a product of combusting fossil fuel, you are reducing your carbon footprint.
Yeah, but it's just to make us feel better. I think it is. And again, I'm a person that wants that. I want to have a backup battery. I have a little homestead, grow vegetables, kill myself, on this thing. But I just I don't know, Jim. I guess I get like, I'm hoping carbon budgets and all that are just not a greenwashing thing. But I understand as a statistician and a data person that you would look at those things as a scientist because nobody's advocating for letting it all go to, well, I'm not advocating for letting it all go to shit. I have no control.
No, we don't have, we can pester the shit out of our, so-called politicians, who are basically bought by the fossil fuel corporations. As I said many times before, us scientists, we do our analyses,
Yeah.
we present our findings, we present our recommendations. Unfortunately, we don't get to implement those policies and those recommendations. It's
Mm.
up to the politicians to listen to us. And so far, they're really not fucking listening to us.
No, they're never going to listen to us. See, I sound like a nihilist, negative person, but what was that on Saturday Night Negative Nabob? Was that who played Ronald
I
Reagan?
have
Oh
no
my
idea.
God, I'm aging myself. Oh my Lord. But anyway, all right. So we move on.
I'm older than you.
So what? Doesn't mean anything. I just remembered this. It just popped to my head because I feel like I'm negative. I feel like it's like
Well,
maybe.
I have all my life I have been accused of being a pessimist and a cynic, and my answer has always been, I'm just being a goddamn realist. Deal with it.
Yeah. And all my life,
I'm
I've
just
been a
I'm just
golden
being
retriever.
I just I'm being a realist. This is what the damn thing is all about. This is what it is.
Yeah, there you go. Let me see. Do I have a sound effect for that? Yes. I have the being a realist. Boom. All right. You got the special
So
one.
that was what Welcome to the Machine by Pink Floyd. Was that sound effect?
Yeah, it could, right? Although I couldn't get a copyright, I have to get everything I get from Epidemic Sound. But hey, they have some
But
good stuff.
it reminded me of that effect from Welcome to the Machine.
All right, guys. Intermission. All right, there you go. We did our intermission. Okay, we're moving on. We're moving on to ocean heat.
Okay.
Yes.
Now, this is really interesting because if the upper panel is one group of folks putting the data together, the lower panel is another group of folks putting the data together. And basically, what we're seeing is they are in agreement. You know? And the lower one is the NOAA one, by the way. But when
I
you
didn't
look at
see
this
that.
here,
Yeah.
we see this is from 0 to 2,000 meters. And again, we just see the continuing adding of heat to the ocean. And by the way, and I'm preparing a video on this, and this
Mm.
graphic is from this video that I'm preparing on.
Oh,
It
good.
Chang just he published it. He seems to publish every January like an ocean update. And what his research has found that in the last 12 months, there has been an additional almost 11 zettajoules of heat energy inputted into the ocean. That's just in the last 12 months. So that's almost a complete zettajoule per month.
Well, since I learned what
And
one was, that's sizable.
and a zetta is 10 to the 21. So we basically talk about
It's high.
11 times 10 to the 21 joules, or 1.1 times 10 to the 22 joules in the last 12 months alone
Alone.
into the ocean.
Now,
In
when we
addition
used to
to,
do our shows and you were talking about this 3 years ago, did you think it would be that fast? Maybe.
honestly, maybe because
Maybe.
of exponentiation and just,
Yes.
but here's the other thing. Okay. Again, I go back to this here, but if you look about, 1996 or so, you see that it transitions from blue to red.
Yep.
I still make the argument
Blue
that
to
that is
red.
when the planet went overall, the entire planet went past the tipping point.
Oh. Well, it
Because
makes sense. It makes
this is
sense.
when the oceans could have dressed their ability
Yep.
to sequester heat and CO2 to depth has been greatly compromised.
Mm.
And basically no longer. And because we keep seeing the added heat, now this is just 0 to 2,000 meters. It's even more so. Most of that is in the upper 700 meters or so. This is another reason that's leading to the increased stratification, and then that heat stays in the upper layers, and it can more readily flux to the atmosphere, creating
Mm.
all the stuff we talked about earlier. But this is when the exponentiation really starts kicking in. In my view, in 1996, that's when we start seeing the drastic rise in the temperature, the increased melting and thawing of ice and permafrost and methane and CO2, et cetera,
Yeah.
et cetera. And don't forget nitrous oxide.
The
That's when we
turn of the
start to see
century.
everything just getting crazy out of control. In fact, you can make the argument that entropy is in place.
Make the argument. Go for it.
Entropy is basically a measure of disorder, and basically we're seeing increasing
Right.
disorder, we're seeing increasing entropy.
Wow. That's pretty heavy. And it's frightening. And we have to deal with our fears, and we have to meet them head on, and we have to keep ourselves sane and focused, and not give up on the things that we feel are important in our lives. Because if I did, I could be a blubbering mess in the living room, and I don't want to do that. And when we're finished, there's a comment by Sacco and Vanzetti I've highlighted. So we'll come back to you. Okay. All right. So I
But
see
there
where
it
you
is.
the tipping point.
That's how much there's how much heat has keeps accumulating and accumulating. Right now, the oceans
Wow.
have been saving our bacons, but they can no longer save our bacons. They're starting to release that heat, and we're seeing what's going
Oh,
on.
you don't want
But
to eat
think about
bacon.
it. They've absorbed 93% of the heat that we've released. That means only 7% has created all the mess we're seeing.
Oof.
Think
Yeah,
about
it's
that.
hairy. I'm thinking about it. I'm thinking about it. Let's take a moment of silence. Hmm. Okay. So now that we've seen that these tipping points here occurred at these times, are there other scientists that have written about that, using this
Oh,
data and say, I mean, there are, but tell us who is, because I think there
they
are.
they 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 discuss tipping points about other things, specific locale. Like for example, whether AMOC will reach a tipping point. Well, AMOC is slowing down. What will the tipping point be? We don't know. Is it
Right.
coming? Probably quickly. Will that help reverse some of the warming? I argue because of all the ocean heat all the heat in the ocean, that any cooling is probably going to be more regional versus say hemispheric as it was in the past. That is where I come from on that.
Okay.
That's others will probably argue with me, fine, whatever. But I'm looking at the ocean heat content in toto, and so that if even if AMOC slows down or stops, any cooling is probably going to be more regional, not hemispheric, because of all the other shit going on elsewhere. Southern
Regional.
Ocean, Indian Ocean, the big huge heat glob in the North Pacific is amazing. That's just sitting there
It's just sitting there. Wow.
and waiting to diffuse. And we're already seeing it by
Mm.
look at what's going on the west coast of North America. You know,
Okay. Wow. Okay. Let's go. Let's go to your favorite one. Let's
this is
the
very
f-
very telling.
yeah, your favorite
Okay,
one.
first of all, let's. This starts in basically 1970 or so. Okay, and it runs to 2022, and this showing the temperature anomalies. How much warmer is going on. Of course, we see the up and down, the cyclical nature of it as typical. But here's the important thing. They indicate to us where El Ninos took place. We see that at some of the upper peaks. They also show us where La Nina took place, and we see that as the troughs, the lower peaks there.
Yeah.
And of course, if you were to fit a line through that, we're going to see a regression line with a positive slope. But here's
Okay.
the amazing thing: we are right now basically in the third year of a La Nina. Now, indicate the indices are indicating we'll probably get to at least the neutral state, perhaps the summer, early autumn,
Right.
perhaps even an El Nino by year's end. That remains to be seen, but that's what the indicators are. But here's and you look at it. Cool La Nina years today are now hotter.
I know.
Could you take that down, please? Are now hotter than the El Nino years used to be less than
Right.
20 years ago. So, in other words, even when we have a La Nina right now, today in 2022, a La Nina is hotter condition than the hottest El Nino of 20, 30 years ago.
And that's
And you can
significant.
look at it. You look at it in the graph there. Look what they indicated the La Nina at the far right there, and then just pick an El Nino from the 80s or from the 90s, and you'll see that the temperature is warmer.
So as we see, everything in every graph goes up in every kind of measurement, in climate, in oceans, in, a lot, yeah, a lot. The peak years are getting hotter, and so are the troughs.
And now someone, I think it was Chris Van Steergen, he basically has floated this hypothesis, which is interesting, that with all the ice breaking off, that eventually, from Antarctica, that
Right.
all the ice breaking off from Antarctica, that it will lead to a permanent La Nina situation in the ocean. Interesting hypothesis. I actually did a video some time ago talking about how icebergs breaking off from Antarctica impacted AMOC. And I said this is interesting study. I'd be curious to see if if they were able to develop further proxy data to back that up, more so than initial. The issue with that hypothesis, and I'm not discounting, I'm just simply presenting what I foresee as probable uh, mechanisms that would need to be, physical mechanisms that need to be overcome. Is
Mm-hmm.
okay. So you have this iceberg moving. It has to first get past the Antarctic circumpolar current. It has to first get past that. Okay, and it's going to be melting. So now you have this freshwater lens. Does it stay as a freshwater lens,
Mm-hmm.
or as you have turbulence, will there be mixing? So therefore, you would then have some diffusion, some modification of the temperature, and then you have to look at the vorticity considerations. Vorticity basically is a fancy way of saying a tendency to rotate. Okay. For example, we've seen the graphics of the Gulf Stream with all those little things pinching off
Yeah.
and twirling around. Okay,
Mm-hmm.
those are vorticity cells. We call them mesoscale eddies. They're basically vorticity scales because
Vorticity
uh,
scales.
because basically, Earth is round. It's got a lot of fluid sloshing on it, and it's rotating. So you're gonna have to balance the pressure gradient, the Coriolis. You have to balance all these different forces, and you
Mm-hmm.
get things tending to spin. So you need to, okay, by vorticity and as well as topographic steering, will you be able to direct this meltwater to the Eastern Pacific, which is where it was likely to end up because you have a thing called Australia in a way.
Right.
So it would kind of funnel the water towards the Eastern Pacific. That
Australia's in the
remains to be
way.
seen. So that remains to be seen
Yeah.
as to whether this introduction of cool water would be able to create a near permanent La Nina situation. Of course, that water is going to be warming as it moves north. So, how much of an effect will that be? And then it's going to encounter the ocean heat content already. Again, how much diffusion and so on. So it's an interesting hypothesis. I am, even if that were to take place because of the ocean heat content, and because of what we just
Mm-hmm.
now discussed, that La Nina years are warmer than the hottest El Nino years of 20, 30 years ago, I almost think well, not almost, I basically think it's not going to make a hill of beans difference. And when we do kick into an El Nino state, things are going to be really, really bad.
Things are really bad. I was just
They're
looking.
bad on it already. They're going to get
Yeah.
really, really bad.
I was just looking at something on Twitter. I was looking for Chris for you and to pull that up, and I'm going to show, let me see if I can get this to show this the picture of the reefs in I'm going to get rid of this, and I think I can get them up. Yeah, there it is. You see that? It was a tourist photo of the Great Barrier Reef posted today, and people are just saying that it's just awful. You know what's happening to the underwater paradise, and somebody said they were shocked at how much the Great Barrier Reef looked just like this photo. Is it the inner or is it the same? You know, they're just shocked because coral should be popping and algae is taking over. So, Jim, that is. Do you think that's from heat? What is it from when this is happening?
Coral bleachings from the increased acidity, I would say, more so.
Acidity?
Because yeah,
Wow.
because the reefs are shallow enough, you get enough mixing,
Mm-hmm.
but with the acidification, you're killing the corals, and the corals have the polyps, and the polyps have a symbiotic algae inside of the polyps that
Mm-hmm.
perform photosynthesis. So that's the basis of the food web. Well, if you start bleaching the coral, you kill
Wow.
off the primary producers. Everything else crumbles from there.
That was that. Yeah. It just came up. I don't. Um, I was looking for Chris because I had seen the tweet, but on Twitter it's very difficult these days to find by putting somebody's name in. And by the way, I wanted to ask you about your Mastodon account, and if you could tell us about that a little bit so we can under because I'm not set up on it at all, and so I don't really know how to do it.
Yeah, back in late October, early November, I was kind of pissed off and fed up with how the shit show Twitter's become. It's gotten only worse. So I set up a Mastodon account, and a whole bunch, like Rick Toman was over there, Brian Brett Schneider is over there,
Right.
and so on. So I set up an account, we had a bunch of followers, and then one day my damn thing just stopped working. Every time I clicked on something, like I want to say edit my profile, invalid token, or report not found, or
Yeah.
I couldn't see my everything was
Yeah.
just not working.
That's
Finally got so,
annoying.
and no matter what, I was trying to fix it and this, that, and the other thing. And I already had, I was already up to like almost 100 followers already. Well, I kind of had to knock the whole thing on its head. So
Wow.
I totally deleted that out. It wasn't working. I couldn't do shit with it,
That's
so,
annoying.
so
Yeah.
totally deleted it out, and I got a different server to create
Oh.
my Mastodon account.
Oh.
So before I was on like what SBH or something like that, SD, I forget what it was. It was something like that. Now I'm just on Mastodon.world,
Oh, all right.
and
So is
so,
Mastodon the
so
same as like Discord? Because we have a Discord, which is a server, and people can join. I wonder, is
I
it
ha-
similar?
I really don't know.
I know
All
it's
I
too
know is
many platforms.
when you go to the Mastodon site, they give you a pile of servers to join, and some of them, like, if you're Scottish, you want to talk all things Scottish,
Okay.
go to this one. If you're French, you want to talk all things French, here, go to this one. So
Right.
there's a whole pile of different ones there. But I just basically totally trashed the previous server. I got rid of that, and so I found this. So basically, I'm using the same Twitter handle. At Jim you know
Yeah,
two
you're still
seven
on
one
Twitter.
two
He's
eight.
he's still
So
on.
I took that same handle, but I
Yeah.
now have it at that same handle at mastodon.world
Mastodon.
or
All
.world.mastodon.
right.
I think it's mastodon.world, but that's where I'm at now, and so far so good. It appears to be behaving itself.
Are
We'll see how
people
long that
coming
lasts.
over there and I mean, is it public? Is it a public sphere or is it all
I
private? Are we
I
in an
post
echo chamber?
No, it's on the public sphere. I've posted a few tweets
All right.
telling folks, "Hey, I'm over here."
I
I
saw it.
updated my profile to reflect it. That said, it's in my profile,
All
my
right.
handle there.
Well,
You'll
then
find me.
everybody
So
go on
update.
over. Yep. Go on
Well,
over,
and
guys.
I'm also going to start posting my videos there as well.
Oh, that's cool. All right.
In,
Wonderful.
in addition to on Twitter and YouTube, I'm going to be posting and
All right.
Patreon. Go to Patreon. So, $3-4 a month, support me on Patreon. But anyway, but I'm going to be
We
posting
all
there
do it.
on Mastodon as well. So
All right. Okay. Um, I do have to ask you, what did you think out of tonight's show would be the flush of the day? I don't see our friend Earl who loves the flush stick, but what do you think? What would we give a flush to? Good rousing flush.
Putin, Putin,
Oh,
piece of
really?
shit.
Okay.
Yeah, he's a piece of shit.
It had nothing to do with our show though. What would you do for the show? What would you flush down
I,
that we've talked about?
I can't think of anything off the top of my head.
Oh, come on. Okay, we're going to flush. I'm going to say it. Uh, we are going to flush that. Okay, we're going to flush Fukushima plumes of shit away. Bye bye. All right, we're flushing them away. Yes, there we go. Okay, that was good. That worked. That worked. All right, now we're going to do this is now the interactive chat time. And I did have some things, Jim, that I wanted to read. Now, obsolete optics, this would take me. He said, can we see a map of ocean heat anomalies, please? Earth, null school, ocean, SSTA preferably, but do I want to do that? I tried to do the tweet. That would take a little work on my part, right? I'd have to pull it up and all. So we'll leave that for Jim to make a video.
Actually, go over
What, you
to
want me to try it?
No. It's not okay. I'm just person can do this on their own.
Oh,
You can go over to my channel, and if you look at some of the recent video there, one of my thumbnails shows the sea surface temperature anomalies.
wonderful. Okay. Then we took care of that one. Let's go back to Jean's question from the very beginning, which I promised. Hello, Sandy. If you get a chance, ask Jim to please talk about how the temperature will affect the ocean currents and what will happen from that. So warmer temperature affecting ocean currents.
Well, okay, keep in mind that surface currents are the result of wind blowing on the water. The wind blows across the water, it pushes the water in motion, and
Okay.
then and usually the water, there's a deflection of about 45 degrees or so from the wind direction, and you then create pressure gradient because you have water higher in certain places, low in other places, so then water flows downhill, and then Coriolis acts on the water, and you get some very nice local gyres that result from from balancing the pressure gradient with the Coriolis and so on. But it all comes from the wind blowing across the water. That's surface currents. Now, with the changing jet streams and the changing temperature gradient, the wind directions might change. So if the wind directions might change, therefore then the water direction might change, which means the surface currents might change. What will happen?
Wow.
So that's this is very, very broad, and that's talking about horizontal surface currents. The key thing is going to be the vertical currents, the thermohaline flow. With the increased stratification, this is slowing down.
Hmm.
That's and with the warming oceans, we get the increased stratification. You're going to get decreased thermohaline, decreased vertical currents. So
Jean,
there's your
did you
30
get all
second
that?
nutshell.
Did she get it? You can rewind it and re-listen. All right, let's see. Who did we have? Oh,
That is an extremely broad overview. You, you can take graduate courses for an entire semester studying this stuff.
Oh yeah, I'm sure you can.
And I've done that. It's all fluid dynamics.
All right, Poppy. But how much more can the oceans absorb? How much more? And that was
That's
from a little bit
that's
into the stream,
well,
but
the oceans
I'm sorry.
can keep absorbing heat, but as the stratification increases, the heat will flux back out. What there is an upper limit to is how much CO2 the oceans can absorb, because as the oceans get warmer, less gas can dissolve, can be soluble. So then less CO2 will be absorbed, and as it keeps getting warmer, the CO2 that's already in solution will come out of solution and go back to the atmosphere. So that will increase CO2 levels, which, you guessed it, will increase warming.
Ugh, oh my God. All right. Let's see here.
WASF, people.
I know. I had the hat up there on Twitter today. Sometimes I don't go on Twitter for days, and sometimes like today, it was on there. All right. I want to address this. Sigh. Les Huskies pack. I wish I had a longer life. I'm only 32, and I had a lot I wanted to do. What a mess the species has made. But you're 32. We don't prognosticate. We don't tell. We don't predict. You're living your life now. You're living your best life. You're living the life you want. You want to help people. You want to do things. You're here with us. You're a person that is a discriminating science follower, understands science. So yes, you are witnessing something that other generations didn't get to witness. So you're here, all right?
I,
Don't
I actually feel I actually feel bad for people,
I know. I
because
know.
we've left them a shit show.
I know. That's my daughter's age, and I
You know,
think
we we
about it all the
we've
time.
we've we fucked up their future. There's some of us have been warning about this shit for some time, but politicians didn't listen to us.
Right.
Right wing crazies didn't listen to us.
It's society.
I actually
Society.
have a video. I'm putting the finishing editing touches on it, and the title of it is "Wally Warned Us,"
Really? Okay. Yeah, about
and
Wally Broker.
it's about Wally Broker, and I cite two papers that he published, one from 1975 and one from 1965, where
Wow.
he warned us of the what burning fossil fuels will do.
He warned
He
us,
warned us.
and Exxon knew and they lied, and I literally
Right.
have that article up because I'm thinking of using that article for Friday night and with Jennifer,
You know,
talking
I might
about that.
I might actually I'm going to actually finish that video. I might actually make that the next one I publish. Wally
All right.
warned us, and just
You
and
should
just
do
put it
that.
out there.
Yeah.
I'm going to do, because
All
because
right.
goddamn, I mean, you know, there's very few people that I actually of scientific community that I look up to. And now Wally was a chemist. Now I'm not a chemist. I'm a fluid
Right.
dynamicist and
Right.
a fisheries guy. Fisheries, fluid dynamics, what have you. But the guy was just brilliant, and so much of what he did is what would he developed a lot of the techniques we use now. He developed the concepts which has been proven correct. There's some things he didn't get correct, and I addressed that in this video. But you know, he was just he was amazing. He was just absolutely brilliant, and some because he wrote this book called Radionuclides, or talking about radionuclides, called Tracers in the Sea. It was published in 73 or so. It's
Right.
still the gold standard. It's still what people refer to. It enabled us to trace oceanic water masses by
So
using the radionuclide signatures.
he's the William Catton of the ocean, sort of, of what he's on par with what William Catton did with Overshoot. Wow.
He
I
he
think
was
you
just
should do
and the
it.
other
Do it, Jim. Do it. Do it. Do
I
it.
mean when Wally passed away, I actually did a special video in memoriam where I eulogized him. The other one is Henry Stommel. He's a physical oceanographer. He developed the mathematics. He explained the Gulf Stream. He explained the North Atlantic gyre. He was able to show mathematically and thus based on the physics why Western intensification takes place in gyres. He did. He
Those are
did all the
good
heavy.
shows.
He built on what he built on what Sverdrup had developed, and what Hansen and other a lot of Norwegian oceanographers were building on. But he built on the work of Sverdrup. But he was able to explain the physics very correctly about oceanic gyres and upwellings and Ekman transport. So he did a lot of the heavy hitting. He was out of Woods Hole and MIT,
Ah,
but his work in the 50s and 60s is just stellar. So I would say between Wally Broker and Henry Stommel, as far as when it comes to oceans,
okay.
it's those two guys.
I should put links then. Okay. I'll put links in the show notes about both of them. So if anybody would like to peruse their
You just do Google.
yeah.
You do it. You can do an
Okay.
ecosia.org search. I don't use Google, so I do use ecosia.org to do my
Yeah.
searches.
Good. Like I use I use a different Brave browser. We don't get ads. Brad said, as the oceans acidify, their boiling point will rise and increase the heat they can absorb before boiling. Ugh. Oh my God. Just sounds all crazy.
Well, the Earth. I mean, the ocean's not going to boil until the sun expands. So but
That's
the
another
ocean's gonna
show.
keep getting- That's another show.
Oh yeah, I
But
got a sun
also,
person coming.
but don't forget, you have salt in the ocean, so there's a thing called boiling point elevation, so that you have to reach a higher temperature than 100 C to boil the oceans because of all the salt. But you will see increased evaporation, which will raise the boiling point elevation. Just like we have freezing point depression, because you have to eject the salt before you form the sea ice. Okay, the you know they the misnomer is that people think sea ice contains salt in it. It doesn't. But to form the ice, you have to make it colder to
Ah,
eject the salt to
oh.
form the ice. It's called sea ice because the source is from the sea. But you can go up to sea ice, chop
That's
yourself a
cool.
hunk of ice there, melt it, and drink it.
That's cool. I like that. I like sea ice trivia, Jim. That's cool. Um, I've got another one, and I wanted to respond to this really quick too. Feeling kind of pretty sad that I have to sit alone to hang out with sane people. Listen, we're all alone, hun, and a lot of us are, and we are doing the same thing. So you're not alone. So revel in your aloneness. Sometimes it's not so bad. I know. I tried with that one. I just wanted you to know that a lot of us are like that. And that's the one thing about social media. If used right, it's a tool and it brings people together, which is what I've done here. So basically. All right. Hi, Max. My friend Kelly, his girlfriend, is witnessing the apocalypse tonight on KMUD radio live stream in Humboldt County, California. Kelly does a show, so I'm going to give her a. She's good. She's good.
I like that. K mud.
Yeah, K Mud. K Mud. Well, wait, Sacco, you're here. You're on this.
That's
You're on this.
appropriate.
But this person, see, you're on social media. You're on a chat of our show, so you can come here then. All right? There you go. I'm accommodating. I'm accommodating. Jim, thank you so much. Thanks for the show. I really enjoyed having you. Is there anything you want to do the wrap up?
Well, thank you everyone for hanging out with us, despite the not very happy sharing of data. But you just do what I do. Put on Emerson, Lake and Palmer.
Or play the YouTube Music Blues all day long and scream and sing so that when you do a show, you have no voice left. ELP, I know you love them. I know you answer all the questions, the music questions on Twitter. I say, oh, it's Jim. He's answering. It's ELP. That's good. That's good. I like that.
ELP, Genesis with Peter Gabriel,
Yeah.
Renaissance,
I liked
from
Renaissance.
Gentle Giant, Triumvirate,
Alan Parsons Project.
Yeah, those, but the guys I just mentioned are like my favorite prog bands.
All right.
And of course, you got Deep Purple Mark II.
Okay. We could do a whole music show.
I'm still stuck in 70s prog rock, and I don't give a shit. That's where I'm going to stay.
That's what you like, baby. That's good for everybody.
I do like Porcupine Tree. I've gotten into Porcupine Tree. I like them. They're good.
Porcupine Tree. All right. Send me a link. Send me a link to Porcupine Tree.
Green Theater's not bad either.
You're cute.
But they do some really interesting stuff there.
Don't we love when Jim smiles? Yes! We love when everybody smiles. All right, but I gotta get up. I cannot sit. Love you, Tanya and Veg is here. Sancho, Sacco, and Vizzetti and Kim. Thank you for moderating. Patty P, Poppy Davis. Yes, Poppy, I know. I'm just going through something. We could write to each other. Kinky Streets and Jim, Raza, it was great to see you, Midas Lisa. I'm glad you could stay up. Human, Jean, BB. All right, Wendy Dalise. It is time for us to go. Goodbye. Mwah! See you guys on Friday with Jennifer.
Thanks for being here.
Yep.